Hey everybody, Brian Hall here from Electrical Tech Skills. Today we're going to talk a little bit about troubleshooting electric motors. This is the first video of a three-part series, and today we'll talk about how to identify when we have a shorted motor winding. Now if we think about electric motors, really an electric motor is just nothing more than a coil of wire. In fact, there's really three coils of wire. Let's call it 6 coils of wire. And generally when we look at electric motors on wiring diagrams, these sorts of things, typically this is how they're depicted. And so really what we have here are 6 coils of wire, and these coils of wire are identical. And so what we can do using an ohm meter is measure between those coils of wire. So if we measured between coil 1 here, 1 and coil 2, and we measured the resistance between those 2 coils of wire there, we see about 2 ohms on our ohm meter. If these coils of wire are identical, if we measure between 2 and 3, the reading should be 2 ohms as well. If we measured between T1, or let's call it T3 there, we should see 2 ohms, right? So they're all identical, and so a healthy motor, the resistance between those readings would be the same. Generally speaking, they should be within about 10% of one another. Now, if we had a motor that had a malfunction, such as a winding was shorted, so in a lot of cases the windings can overheat, the windings are separated by varnish on the wiring, and that varnish insulation can break down and create shorts in the wiring. And so this would be a depiction of a shorted winding. So if we were to measure between T1 and T2 there, the resistance would be, let's call it 2 ohms. Now if we measured between T1 and T3, because we have a short in the winding, the resistance is going to be less. So if we saw less resistance between T1 and T3, or T3 and T2, because we also have a shorted winding there, then we would know that we have a short circuit, right? Again, what we're looking for really is to make sure that the readings between the coils are all the same. If these are drastically lower than one of the other readings, we've got a shorted motor. Okay, so let's demonstrate how to use a multimeter, an ohm meter, to be more specific, on how to identify whether or not an electric motor is in a good working condition. So as we mentioned in an earlier video, when we measure between each winding of the motor, because the windings are identical, the readings should be the same. So I've disconnected the motor windings or motor leads from the bottom of my motor starter here, and so these wires go out to my motor. And so if I measure between winding number 1 and winding number 2, you notice there I read about 10.8 ohms. So I should find about 10 ohms, plus or minus a few tenths of an ohms, between motor winding number 1 and motor winding number 3. And sure enough, about 10.8 ohms, almost exactly. And so if I measure between motor winding number 1 and motor winding number 2, number 2 and number 3, again, I read about 10 ohms. So each one of the readings are consistent, so my motor is in good working condition. Each winding is exactly the same. The motor is in good shape. Okay, so this is part 2 of our troubleshooting an electric motor using an ohm meter of our 3-part series. And so today we'll talk a little bit about how to find an open motor winding. So in previous videos we talked about motors being just 3 coils of wire essentially, and those 3 coils of wire are identical. And so if we were to take an ohm meter and measure between the first coil of wire and the second coil of wire, or windings in our motor, let's say for instance we would read about 2 ohms. And so if we were to measure between 2 and 3 there, because again those motor windings are identical, we should see about 2 ohms. And so the same thing would take place if we were to measure between 2 and 3, 2 ohms. Again, all 3 windings are identical, and so the resistance reading should be about the same. Now if we had an open winding, let's say that we overheated the motor, and the wiring in the motor overheated to the point where we opened up, or the wire actually broke inside of the motor. Now when we measure between T1 and T2, we have completed coils there, and so we would have continuity, and let's call that we measure 2 ohms. Now, if we were to measure between T1 and T3, because we do not have a complete circuit there, the winding here is broken, we would not read any continuity, and so we wouldn't measure any resistance, and so consequently we could determine that the motor winding is open. Same thing would happen if we were to measure between 2 and T3 there. We wouldn't measure any continuity, or again, no resistance reading there, because we do not have a completed circuit. The wire is broken. Okay, so let's demonstrate how to use a multimeter, ohm meter, to find an open motor winding. So again, I'm going to start here at my motor starter, and I've disconnected the wires that go out to the motor from my motor starter. And you notice there the wires are labeled 1, 2, and 3. And so again, if we measure between our windings, ultimately that's where these wires go to the windings in the motor, the resistance readings should be the same. And so in this case, I'm reading about 10 ohms. If I read between, that was between motor winding 1 and motor winding number 2. Now if I read between motor winding number 1 and motor winding number 3, if you notice there, we don't get any resistance reading there. We have open loop. The meter is telling us there is no continuity, and so there is an open in the wiring here. Now it could be between the motor starter here and the motor itself, so it could be the wiring in my conduit here going out to my motor. So the next step in my troubleshooting process would be to take the cover off of my motor connection box and perform my resistance test at the motor itself. In part 3 of our 3-part series of troubleshooting electric motors, let's talk about a grounded winding. Okay, so in electric motors, the metal case of the motor will be connected to ground. And so we would never want any of our motor windings connected to our ground. And so if we were to measure between winding number 1 here and ground, we should not have any resistance, or there shouldn't be any continuity between motor winding 1 and ground. Same thing with motor winding 2 and ground. There shouldn't be any continuity. We do not want one of these energized windings connected to our grounded case of our motor. Same thing with winding number 3 here. We would not want it connected to ground. Okay, in the event that there were a grounded winding, so in this case, let's say winding number 1 was connected to ground, or we have a grounded winding here. If we measure now between winding number 1 and ground, and we measure resistance, okay, or very low resistance, now we know that those two are connected, and we have a motor that is malfunctioning. Okay, so let's demonstrate how to use an ohm meter to find a winding in an electric motor that's shorted to ground. So again, the metal case of the electric motor will be grounded, and so there is a ground wire that goes through the conduit here and connects to the metal case of the motor. And so what we would not want is any of our motor windings to be connected to the grounded case of the motor. And so we could determine that by using again our multimeter set to an ohms function. And so if I measure between winding number 1 and ground, we have an open loop, right? So there is no continuity, and so again, that's what we'd want to see. We wouldn't want motor winding number 1 connected to our case of our motor. So let's move over to winding number 2, and so again we see an open loop there. Motor winding number 2 is not connected to our grounded case of our motor. And so let's go to winding number 3, and sure enough we see about 0.2, 0.1 ohms. Actually now we're seeing 0 ohms, and so what we do have is winding number 3 is connected to the motor grounded motor case here, and so we have a shorted winding to ground.